Hi everyone, for this UNP podcast, I am joined today by Elizabeth DuPre, who is one of our student scholars. And so thanks for joining us today, Elizabeth.
Thanks for having me.
So to begin with, could you tell me a little bit about your background?
Yeah, so currently I'm a PhD candidate in the integrated program in neuroscience at McGill University. Before that, I did a master's in developmental psychology at Cornell University, and I also did my bachelor's at Cornell University, also in psychology.
And what do you currently work on?
Yeah, so despite having a very psychology-oriented background, I've recently gotten quite a bit into neuroinformatics, mostly because I had a lot of, I think, really interesting and important psychological questions, and I realized that the tools that I needed to ask those questions didn't really exist. And so I started to work a lot more on neuroinformatics to figure out how we could create the tools and manage the data in such a way that we could actually ask these kinds of scientific questions. So in my current lab, I work with Dr. Jean-Baptiste Pauline, and I'm really involved in, right now, actually working on validating a method that we use to functionally align data sets. So to try and make it so that different participants are more comparable with one another.
I guess neuroinformatics has a lot to do with programming and these types of things that you're not necessarily thought of in psychology. Was it the case for you, or did you have to learn all that on your own?
Yeah, no. So neuroinformatics is a lot of programming, and unfortunately, you're right. So I did psychology, and in the program I was in, there wasn't a lot of emphasis on coding. I think that's changed more recently since I went through, but at the time there really wasn't much at all. It wasn't until my last year that I even was taught any R, which I love. But more recently, so when I graduated from undergrad, in between undergrad and my master's, I worked for a little bit, for a couple months, and I was working as an RA in a lab, and I had a lot of data to process. And I realized my two options were to spend basically all day, every day, clicking buttons to process the data, or to teach myself to code so that I could process the data more quickly. And because I'm lazy, I decided that coding would be the better option. So I taught myself to code so I would have to press fewer buttons. But a lot of really good things have come out of that. In particular, since I've become aware of the world of open science since then, it made a lot more sense to be like, look, I don't have to rely on my memory of which buttons I pressed. I have the exact code. You can see exactly what I did and share that. So I think a lot of good has come out of it. But yes, it was a little bit of a learning curve in the beginning.
How did you first learn about open science?
Yeah, that's a great question. I feel like there's always those things in your life where it seems so central, but where you look back at where it started, it's very fuzzy. It feels almost like a fluke. So for me, I think I had started coding a little bit, and I had actually started putting my code online, but it wasn't really intentionally. It was more just to have a way to keep it organized and to make sure I had access to it, which I think is a huge benefit of services like GitHub. But then I actually signed up for Twitter for a totally different purpose, which was that I'm also very interested in science communication. And I had gone to the Communicating Science conference at Cornell. And they had recommended that everyone get a Twitter because it's very important for science communication. And so I got on Twitter and I started following all these scientists I knew, and they recommended this brand new program at the time. It was going to be the first iteration of what was then called NeuroHack Week. So I signed up for NeuroHack Week with the intention of learning how to code a little more and learning how to be a little more efficient in my work. But when I went there, I was really exposed to not only the idea that all of these things that, we talk about like sharing code and sharing data were actually more efficient, but they were also better for science overall. And so I left that event and I realized there was this whole world that I hadn't really seen before. And I got really excited about finding out about it.
And in your research activities, do you currently produce data or you tend to reuse data?
So in my PhD right now, I'm just using open data. I'm not producing any data. In my master's, we did release some data. So I've been kind of on both sides. And I'm always super, super grateful because I know it's a lot of work to release a data set. So now I'm mostly taking advantage of lots of other people's very hard work.
And have you encountered any problems so far for your PhD work?
Have I encountered any problems? So I think it's getting, I think it hasn't been too bad, really. One thing I would say, we just wrote a little perspective piece about this, is that because what I'm interested in doing is using this method to kind of align people, the data that we usually use is naturalistic data, so really rich, complex data sets. And usually what people will do to collect those data sets is they'll show participants a movie in the scanner, or they'll play an audio clip like music or a podcast. And we actually have come to realize one thing that's kind of been problematic is that because these are often copyrighted materials, the researchers aren't then able to share the stimuli that they showed. So it's hard to know what the participants actually saw during the study. So that was something we recently wrote a little piece just to kind of hopefully draw attention to this, that for me working on this method, it's really useful to know the kinds of stimuli that the participants actually saw. And when we're sharing open data, we also really need to think about, the kinds of stimuli that we're sharing, and whether or not those can also be accessible while staying on the right side of copyright law, obviously.
And if you were to, I guess, keep working in the field of research, would you change anything to your research habits or open science practices?
Yeah, no, I think that's a great question. I think, so one thing that I'm really very passionate about, but I'm really not sure how it's going to fit into the scientific landscape overall, is open publishing. And when I say open publishing, there are a lot of directions within that. One is open access, which I think is making a lot of strides. Another is this idea of helping overcome research debt, which is this idea I've stolen from Chris Olah and Sean Carter in a Distill piece, editorial they did. But basically the idea is that right now we create PDFs, and sometimes they have links out to the code and data, but often what you read in the PDF and what you see in the code aren't perfectly aligned, and it makes it that much harder to kind of build on researchers' work.
Right.
And so I think there's some really, really exciting initiatives coming out like NeuroLibre, and maybe Aperture from the OHBM community, which are helping to make it so there's a tighter integration between your actual, the text, your narrative, and your research products. So like your code, your data, your stimuli. I think that's what I would really like to see. That's what I would really like to see more broadly for the research community. And that's what I hope I can do more in my own work moving forward. But I think it's going to take a sea change. I'm hopeful we're close.
Elizabeth, could you tell me a bit more about your CONP project?
Yeah. So for my CONP project, what I'm really interested in is I'm working with Nicolas Dikoff and my advisor Jean-Baptiste Pauline, and basically Nicolas had started this really amazing collection of tutorials to showcase concepts in quantitative MRI. And one thing I realized that looking through these is that they were really, really amazing and information rich, but they weren't taking advantage of kind of the broader open publishing ecosystem that's come about. So in particular, from the Jupyter community, Jupyter Book, where Chris Holgraff has really kind of driven this forward, is a new project that's designed to take a collection of Jupyter notebooks and Markdown documents and turn them into something that resembles either a course textbook, or I'm really pushing on it to resemble like a traditional scientific publication. So you'd have everything you want from a publication, like sidebars and figures and a bibliography, but you can just create it right away from your Jupyter notebooks or from your Markdown files. And so that we hope will make it much easier to do a really tight link between your actual scientific process with all your research products of code and data and stimuli and your narrative text.
And do you have any like scientist, role model, or person that you look up to?
Too many.
Too many.
There's way too many.
Well, we can name a few if you prefer.
I think there are a lot of people out there doing really amazing work. So I think for me, two people I've been really, really lucky to work with who I think have done amazing stuff are Ariel Rokem and Fernando Perez. So Fernando is a professor at UC Berkeley and Ariel is at University of Washington eScience Institute. And they've both done a lot of work in their own disciplines. So Ariel is a neuroscientist, Fernando is a geoscientist. But they've also kind of done this amazing thing, which is to create tools that really easily translate across disciplines in a way that I think is really impactful and profound. Because the longer I've been in science, the more I realize how many problems we share across disciplines, and that making tools such that we can actually take advantage of one another's work is really, really important. Yeah, there's a lot of people, but I think those are the first two I'd say.
All right. Well, thank you very much, Elizabeth, for your time.
Thank you for having me.
And we are looking forward to hearing more from you in the future. And yeah, thanks.
Thank you.